will higher thermal conductivity always result in faster heat dissipation? Have you ever wondered if a material that conducts heat better will always cool down faster? This question is more complex than it seems. Let's break it down together. Higher thermal conductivity means a material can transfer heat more efficiently. This property is measured in watts per meter Kelvin and indicates how easily heat moves from a hot area to a cooler one within that material. Metals like copper and aluminum are great examples of materials with high thermal conductivity. They are excellent at transferring heat. On the other hand, materials like styrofoam or mineral will have low thermal conductivity. These materials act as insulators and slow down heat flow. However, just because a material has high thermal conductivity does not mean it will always lead to faster heat dissipation into the environment. Several factors come into play. First, consider the temperature gradient. Heat naturally flows from areas of higher temperature to those of lower temperature. A larger temperature difference between the heat source and the surrounding environment will drive faster heat transfer. Next, think about thermal resistance along the path. Heat must pass through various layers or interfaces before it reaches the environment. Even if one layer has high thermal conductivity, other layers with lower conductivity or poor contact can limit the overall heat flow. Then there are the heat transfer mechanisms at the surface. Once heat reaches the surface, it dissipates through convection, radiation, or conduction to another medium. The efficiency of these processes, described by heat transfer coefficients, strongly influences how quickly heat can dissipate. Another important factor is thermal diffusivity. This property is defined as thermal conductivity divided by volumetric heat capacity. It shows how quickly a material's temperature changes when heat flows through it. A material with high thermal diffusivity reaches thermal equilibrium faster, but that does not necessarily mean heat leaves the system faster. Lastly, the geometry and surface area of the material matter. The shape and size affect how much surface area is available for heat exchange. Larger surface areas can dissipate heat more quickly. In practical applications, materials with high thermal conductivity are often used in heat sinks. These components draw heat away from electronic devices and spread it out for faster dissipation. However, the overall cooling performance depends on the entire heat transfer path. This includes how well the heat sink contacts the component, the airflow around it, and the ambient conditions. While higher thermal conductivity helps with internal heat transfer, it does not automatically mean faster heat dissipation to the surroundings. Effective heat dissipation requires considering the entire thermal resistance path, surface heat transfer mechanisms, and environmental factors. Understanding these principles can lead to better designs for systems that manage heat efficiently.